Hey class, since the solving rational equations assignment was omitted from your course schedule, I wanted to practice a couple of these types of problems to make sure that you are ready for this on your quiz. So here are two different examples. One's a word problem, one's just an equation. The word problem says a triangle has an area of 6x squared minus 54 inches squared. The length of the base is x minus 3 inches. What is the length of the height? So our job is to find the h, we know the b, and we know the area, the a. So we have to think about the area formula for a triangle first. And if you recall, area of a triangle is 1/2 the base times the height. Okay, so now I'm going to sub in 6x squared minus 54 for the A. And we're going to leave the 1/2 there. We're going to sub in x minus 3 for the B. And then we're going to have the h left over. Okay, so if our job is to solve for the h, because it's asking us what is the length of the height, then we need to get that isolated. So since all of these are held together by multiplication, the inverse operation to get them apart would be division. So if we divide by 1/2 times x minus 3, we will get the h by itself on the right-hand side of the equation. Sorry, that should be a 1/2. 1/2 times x minus 3. Okay, so now what I would do at this point is try to factor the numerator. Since the denominator of the left-hand side already looks factored, we may have a factor cancel out. So if I factor the numerator, first what I would want to do is probably take out a GCF. I'm going to move over here to the right side of my page. So the GCF of the numerator would be 6. Both of those terms are divisible by 6. And when I take out a 6 from 54, negative 54, I get a negative 9. Okay, then the next thing I would do is break down my x squared minus 9 into difference of two squares. So it could be written as 6 times x minus 3 times x plus 3 over 1/2 times x minus 3. And now we should be able to cancel our x minus 3's. So we have 6 times x plus 3 over 1/2. It's still a little bit messy, or 6 times x plus 3, I'm sorry. What I would do is to not have the fraction of 1/2 in the denominator. I would multiply by the reciprocal of 1/2. This is how you handle complex fractions. The reciprocal of 1/2 is 2 over 1. So what's going to multiply together here are the two numbers, two constants. So we're going to get 12 times x plus 3. And remember, that is equal to the right-hand side of the equation, which was h. So we just solved for h. It would be that in inches. So that's one example of a solving equation where you had to come up with the equation yourself and then you solve it. Now, the bottom equation I'm going to do in green work so that we keep it separate. What we need to remember here is that because we are adding and subtracting fractions, you need a common denominator. So the first thing that we need to do for this is make sure that we can factor the denominators and see what the common factors are so that we can get a common denominator. So if I factor my left-hand denominator, I'm going to get m plus 5 times m plus 3, because 5 times 3 makes 15 and 5 plus 3 makes positive 8. And then we have 1 over 1 minus 1 over, if we factor this denominator, we take a 2 out as the GCF, and we have m plus 5. Okay, so what we need to do at this point is make sure that all of our denominators become the same, because once they're the same, then we can work entirely with the numerators and just completely disregard the denominators. So in order to make them all the same, they need to have 3 parts. Part 1 would be the 2, part 2 would be m plus 5, and part 3 would be m plus 3. So as you can see, some of those denominators have 2 of the pieces, and then the 1 over 1 has none of those. So we are going to need to multiply the different fractions by the pieces that they are missing on the numerator and the denominator. So for example, our left hand side is missing the 2 that we want it to have from the denominator. So this needs to be multiplied by 2 over 2. Now our 1 over 1 is missing all of it. So this needs to be multiplied by 2, by m plus 5, and by m plus 3 over 2 times m plus 5 times m plus 3. And I'm leaving it in that factored form. And last, our minus 1 over 2 times m plus 5, that's missing the m plus 3 factor, so that's what it needs to be multiplied by. Okay, so what we are going to do is now multiply all 3 of these terms. We'll get 2 over 2, what I wanted to do, 2 times m plus 5 times m plus 3 on the left, I'm leaving it in factored form, equals 2 times m plus 5 times m plus 3 over 2 times m plus 5 times m plus 3 on the right, minus m plus 3 over 2 times m plus 5 times m plus 3. Okay, so now all of our denominators are the same. They all have the 2, the m plus 5, and the m plus 3. So what we can do at this point is completely disregard them and work this entirely with just the numerators. What we need to do with the numerators is go ahead and distribute and not leave it in factored form anymore. So mainly this piece. We know that m plus 5 times m plus 3 is the m squared plus 8 m plus 15, because that was where it came from over here. So we really have 2 times that in the numerator. So we want to distribute that 2 to all 3 terms. This 2 is just going to be over on the left-hand side of the equation. And on the right-hand side of the equation, we're going to have more terms. So we're going to have 2m squared plus 16m. This is from me distributing the 2 to the trinomial, plus 30. And then my negative sign distributes. I'm like adding the opposite of both of these signs because I was subtracting the binomial. So I'm going to get a negative m and a negative 3 from that last numerator. So now I'm going to combine my like terms, set it equal to 0, and solve. So what I should do is get my 16m and my negative m and my positive 30 and my negative 3 to combine. We also need to subtract over the 2 to set it equal to 0. And so we should get 0 equals 2x squared plus 15m, because we subtracted 1m from 16m. And when we combine all of our constants, we have 30 minus 3 would be 27, minus 2 would be 25, positive. Okay, so we are almost done with this problem. Now we just need to factor this quadratic and solve for m or x. At some point, I switched my variable there. So to factor this trinomial, I am going to multiply my 2 with my 25 to give me 50, and my b term is what they have to add up to give me, and that's 15. So two numbers that multiply to 50 that add up to 15. Hopefully you're thinking of 10 and 5. 10 times 5 is 50, 10 plus 5 is 15. So we are going to replace our middle term with a 10m and with a 5m, and then we can factor it by grouping. So I'll take out a 2m times m plus 5, and I'll take out a 5 times m plus 5, and we factor it as 2m plus 5 times m plus 5 equal to 0. We set each of these inside equations equal to 0, and we get m equals negative 5 halves and a negative 5, because we have to change the sign. Our final step of this problem is to sub in both of these values in where there were m's in the original problem and make sure that they do not give us 0 in the denominator, because that is undefined, and so that would have to be an excluded value. So if we sub in negative 5 halves to the m squared, you need to type that into a calculator. You will get 1.25 from this denominator. And if you sub it into this denominator from our original, subbing in negative 5 halves, you are going to get a positive 5. And so because neither one of those is 0, that one works. However, when you sub in negative 5 into both of those equations, for the left denominator, you will end up getting negative 5 squared. It's 25 plus 8 times negative 5 is negative 40. So we're at negative 15 plus 15. You get 0. Sorry, I did it again. 0. You also get 0 over here when you sub in negative 5. And so this one needs to be excluded, and our final answer to this second question solving is just m equals negative 5 halves. So as you can tell, the adding and subtracting, solving rational equations questions are very time consuming. They take a lot of work. Make sure you get a common denominator. Then once you have the common denominator, you can completely ignore it and just focus on the numerators. And then once you solve from only the numerators, you need to sub in both of your values, or as many values as you get